Question of the week from the Naked Scientists.
Hello and welcome to Question of the Week. This week's question might need a moment to sink in, and it's from listener Richard.
Will a can of soda dropped in the ocean sink until it implodes, or will it float once the density reaches equilibrium?
There's only one way to find out what happens to a can in the ocean: an experiment. I don't have an ocean, but I do have a really big pot I can fill up. Okay, that's 3 litres, so if I add 6 tablespoons of salt, I think that should roughly make seawater. Let's give it a stir. Salty. Okay. And I've got a can of Coke. Let's see what happens. It floats. Interesting. Yeah, right there on the surface. Richard, the cans failed your question at the first hurdle. It would have to be denser than the water to sink before we could learn whether it would implode or hover at a fixed depth. But that's not the end of it, according to Mia Fulks from the Cambridge Science Centre.
This is a really interesting and deceptively complex question, and depends on which country you're in. In the UK, fizzy drinks contain less sugar, so the can will always have a lower density than water and float. Other countries will add more sugar, so their cans of soda will sink.
The difference even extends to diet versus regular drinks. Regular Coke will sink, while Diet Coke will float. So let's take the sugariest of US fizzy drinks as our example, which is going to have a density of a little over a gram per milliliter.
Ocean water is at that density at about 5,000 metres below the surface. If our can sank to 5,000 metres, it would subsurface float because of the equal densities. But it's unlikely the can would get that deep. At 5,000 metres, the water pressure would be around 50,000 kilopascals.
That's 500 times the pressure of the Earth's atmosphere.
So, if a can of soda sank in the ocean, it would be crushed before it started floating.
On the forum, user Halk has speculated how this might happen. The can is a nice symmetric shape, so it's going to keep its shape for a while, but eventually the top of the can will begin to bulge inwards. Given enough pressure, it will probably dent somewhere, allowing the two pressures to equalize. It won't ever completely implode. The liquid in the can isn't compressible enough.
Interestingly enough, the average depth of the ocean is 3,700 metres. So, in many places, the can couldn't possibly get deep enough to float, even if it could survive the trip down.
Thanks very much to Mia Fulks for that answer. For now, see you later, alligator, because next time we're answering this question from one of our younger listeners, Johan.
I'm Johan from California, and why crocodile skin are so bumpy and not smooth?
Can you help Johan with their question? If so, come and join the discussion over on our forum, nakedscientists.com/forum. Or if you'd like to ask a question yourself, email chris@nakedscientists.com. I've been Phil Sansom, and until next time, goodbye!
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.